Hello class and welcome to section 9.2, Logarithms and Logarithmic Functions. Today we're going to go ahead and discover what are logarithmic functions. Okay, so first of all what we're going to do is we're going to look at an exponential function. So it says consider the graph of y equals 2 to the x and its inverse. So remember 2 to the x is an exponential function. We just talked about that the other day. So we're going to consider this exponential function and its inverse. Since exponential functions are 1 to 1, okay, the inverse of y equals 2 to the x is also a function. Okay, since it's 1 to 1, for every input of x, there's only one output of y. So that means you can find the inverse. So recall that you can graph the inverse of a function by switching x and y. So let's just go ahead and start out looking at, we were first calling our attention to y equals 2 to the x. Okay, so if I take and I plug in these x values, these are the y values that I will get out. So remember, to find the inverse is when you switch the x and the y values. So if you look to the right in this column, I have x equals 2 to the y. So I switched x and y. When you do that, okay, notice what also happened. My columns here, my x values are now in my y value column. And my y values, okay, are now my x values. So notice how they switched. These literally are flipped from the equation on the left-hand side. Okay, so these are reverse of what they had. So graphically, if we go ahead and look at this, my exponential function, y equals 2 to the x, is this function in the blue, or I'm retracing over it in the green. This is my exponential function. I remember when we talked about functions with inverses in the past, we've talked about how they will go over the asymptote y equals x. Okay, they will go across that line, y equals x. So if I graphically look at my inverse, my exponential, and I reflect it across the y equals x axis, I will now have a function like this. Okay, this is what we call a logarithmic function. So a logarithmic function is the inverse of an exponential function. Okay, so there's another way that we write logarithmic functions. We typically don't write it x equals 2 to the y. So we're going to figure out how to convert in between that. So we have logarithms. Okay, that's what I said the inverse of an exponential is. So there's logarithms with base b. Okay, so the inverse of y equals b to the x, and remember before we were looking at y equals 2 to the x, okay, is, so the inverse is just when you switched it. We said it was x equals 2 to the y. Okay, so that's what this notation is saying here. So what we do is it says y is called a logarithm of x, which is written as y equals log base b of x. So using this piece right here, this is the way we rewrite this. Okay, so really y is my exponent. Okay, see that's my exponent here. B, well I have 2 on this one, but it's right here is b. B is my base. Okay, so it's the bottom part, whatever's being taken to the exponent. And x. Okay, that's what the answer is. Okay, this is whatever the answer is. So today we're going to work on converting in between logarithmic forms. So this is my answer. So y is the exponent, b is the base, and x is my answer. Okay, so let's go ahead and just look at some examples. Write each equation in exponential form. Well, let's start with my base. Remember we had log base b of x is equal to y. So my base b, this is my base. Okay, so I have 8 to the, my exponent was what it was equal to. So this is my exponent, the y. So in this case, this is my exponent. So it's 8 to the 0, and that equals what x is, the answer, 1. Is it true that 8 to the 0 is equal to 1? Yes, it is. Okay, so that's my first logarithm. Let's go ahead and look at example B. We're going to rewrite this one. Okay, so I would have my base again, always log base b. So here's my base. So I would have 2 to the, my y value, which is -4, and that is equal to the x value, which is 1 over 16. So there it is in exponential form. And is it true that 2 to the -4 is equal to 1 over 16? That is correct. Moving on to example C. Do the same thing. My base, in this case, it's log base b. Okay, so this is my base. So it is 4 to the, this is my exponent. So 4 to the second equals my answer, which is 16. That is true. 4 to the second is 16. So there it is in exponential form. Now we're going to go ahead and write it in logarithmic form. So now I have the opposite. I have what we came up with our answer from before. So I have a is 10 to the third equals 1,000. Well, let's start with what my base is. My base is right here. So it is log base 10, so it's like a little 10, to the, okay, log base 10 of the answer. So this is my answer. So 1,000 is equal to the exponent, which is 3. Okay, so just regrouping it back together. Let's go ahead and look at example B. Example B, we have 9 to the 1/2 is equal to 3. We know that that is true, but now let's put it in logarithmic form. Okay, remember my base, this is B. Okay, it's log base B, so log base 9 of the answer, which is 3, is equal to 1/2. Okay, so just rewriting it, working our way back. And example C, this one will be log, who is my base? Who's got the exponent being taken to it? 125. So log of 125, okay, is equal to the answer. Sorry, log of 125 is the answer, is equal to the exponent. So log base 125 of 5 is equal to 1/3. Okay, so there it is in logarithmic form. Now we need to go ahead and we need to evaluate each logarithmic expression. So looking at A, okay, we have log base 2 of 64 is equal to y. So let's just go ahead and rewrite it how we have been in the past. Okay, so my base is 2. So it is 2 to the y is equal to 64. Okay, so if you don't know, you would get out your calculator and start trying it out. Okay, we know that 2 to the first is 1. So we know y is not 1. So we know 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 16, and then I would try 2 to the fifth. I would just keep trying all these on my calculator till I would get to my answer. This is 32, and 2 to the sixth is 64. So it's a little bit of a guess and check, but would we really have had to just start with these lower numbers? Most likely not. Okay, so now I know it's 2 to the sixth is equal to 64, so y is equal to 6. Let's go ahead and take a look at B. We need to go ahead and evaluate this one. So we have log base 3 of 81 is equal to y. So I have my base is 3. 3 to the y is equal to 81. So once again, if you don't know, you just start plugging it into your calculator till you get something. We all know that 3 to the third is 27. Okay, so I would maybe just go ahead and check, well, what is 3 to the fourth? 3 to the fourth is 81. So filling in what I know y is equal to 4. So it might be a little guess and check, okay, but that is how you're going to get these problems done. Okay, we'll find out other methods to solve them later. But for today, that's how we're going to do it. Example C, okay, it's log base 4 of 256 equals y. So my base is 4, so it's 4 to the y is equal to 256. Okay, so you get out your calculator and you get trying, and you will find that 4 to the fourth is equal to 256. Okay, so that is example C from 3. Now is a good time. If you have any questions, please write them down. If you'd like to take a break, feel free. Pause the video, take a break, and then we'll move on. So, logarithmic functions. Okay, logarithmic functions have the following properties. The function is continuous and one-to-one. Okay, so continuous means you can draw it and not pick up your pencil. So logarithmic function, just so that you know, graphically looks like it does on the front page. Okay, so there's my logarithmic function. The domain is the set of all positive real numbers. Okay, the y-axis is an asymptote of a graph. So my y-axis is this one. So really it means there's an asymptote here, and this is where x is equal to 0. So there's an asymptote at x equals 0, or the y-axis. And then the range is a set of all real numbers. Okay, so my range is going to cover everything up and down, but my domain is just the positives. Okay, only positive x values. You cannot take the log of a negative. And the last thing is the graph contains the point 1, 0. The x-intercept is 1. So this point right here, maybe I can do it in a different color. This point right here is the point 1, 0. Okay, so just a few things to remember. So the function is y equals log base b of x, where b is greater than 0 and it cannot be 1. Okay, b cannot be 1. If you need to pause the video to write down these descriptions of a logarithmic function, please feel free to pause the video and write it down because there's a lot there. All right, example 4, we're going to move on. We're going to do some more solving of logarithmic equations. So I have log base 4 of n is equal to 5 over 2. So let's go ahead and just write this into exponential form. Okay, so it is really log base 4 to the 5/2 is equal to n. Okay, well, I might not know what that is right off the top of my head. There's some ways we could think about it. You could rewrite it as it's really 4 to the 1/2 to the 5th. And remember, the 1/2 power is really the square root of 4 to the 5th. So this is 2 to the 5th, which gives me 32. So I could figure out n is equal to 32. Or the other way is, you guys like to make life easier than that, you can literally go and type this in on your calculator. And you would do 4 to the 5 over 2. Biggest thing to do is remember that you need to put your exponent in parentheses. So if my calculator gets pulled up here, I will quickly show you how to do that. While we're waiting for that, why don't you go ahead and start B and C. Do B and C real quick, or at least try B on your own. All right, so in order to calculate this on my calculator, I would do 4, and then you guys remember the little caret means to do an exponent, and then you need to put parentheses unless your calculator automatically does it, like on this calculator it does. Most, I don't know, half and half the calculators probably do and don't. So just be careful. So it's 4 to the 5 divided by 2, and the parenthesis. And that will give me my answer of 32. So that's how you would do it on your calculator. Okay. Example B. Hopefully you had a chance to look at that one. So we have log base 9 of x equals 3/2. So it's base 9 to the 3/2 is equal to x. So once again, you'd type it in on your calculator, and in this case, you'd get x is equal to 27. Example C, a little bit different. Okay, log base b of 121 is equal to 2. So it's base b to the second is equal to 121. I have to do a little bit of solving on this one. If I want to get b by itself, I have b squared. The way I get rid of that is to take the square root on both sides. So b is equal to the square root of 121. And the square root of 121, if you don't know it, you can do it on your calculator, is 11. All right, we have two more sets of problems to look at. The next one is exponential inequalities. Okay, so if b is greater than 1, which it has to be for logarithmic, and x is greater than 0, okay, notice how these are exactly the same, then log of base b of x is greater than x, then is greater than y, excuse me, then x is greater than b to the y. Okay, here's the biggest thing to remember. Do you guys remember when we started inequalities? This is a greater, so it was an or. Okay, the next one is a less than. So we would think and. So it's an and statement, so it's a compound. Okay, so this one, they're the same except for when it's less than, it's compound. Okay, and if it's greater than, you're only going to have that x is greater than b to the y. Okay, so let's just look at an example. I feel like that's the best way to do this. Okay, so we have log base 5 of x is less than 2. Okay, so since it's less than, it's going to be a compound statement, and we will always have 0. Okay, so it's always 0 is less than x, is less than, and then I get my solution by taking base 5 to my answer, 5 squared. Okay, so it's 0 is less than x is less than, well, 5 squared is 25. Okay, so if it's a less than, it's going to be a compound, and my way of recommending to remember it is that and. I know it's not really a less than, but a less than. Okay, so remember that and. Okay. If it's a greater than, okay, if it's a greater than problem, okay, the answer will just be that x is greater than my base to the answer, 4 to the third. And 4 to the third is 64, so x is greater than 64. All right, then example C. Less than, so it's an and, so it's a compound inequality. So we always have 0 is less than x is less than, well, now I just put it in exponential form. Base 2 to my answer, which is 4. So 0 is less than x is less than 2 to the 4th is 16. So there is my solutions to those equations. And my last set of problems is to solve the logarithmic equations, okay, that have logarithms on both sides. Just want to bring you back. Do you guys remember in our last notes we had, let's say, 3 to the x plus 2 is equal to 3 to the second. Okay. Well, you just took your exponents since my bases were exactly the same and set them equal to. Same type of idea here. If your logs are exactly the same, what's on the inside we can just set equal to each other. So this is log base 5 of x squared minus 2 is equal to log base 5 of x. So they are exactly the same. Okay, so I can set them equal to each other. So I'd have x squared minus 2 is equal to x. Now I need to solve it. Okay, here's the thing. This is a quadratic, so I need to get everything onto one side, so I'm going to subtract x. Now I need to factor. What multiplies to negative 2 but adds to 1? Well, negative 2, positive 1. Okay. Now I would set each one equal to 0. Add 2, so x is equal to 2. X is equal to negative 1. Okay. Now you need to be careful because our log functions, our characteristics was that the domain was only positive numbers. So if I think about it, if I plug in a negative 1 here, I will have an error. Okay, you cannot do this. Okay, so x equals negative 1 is not a solution, just x equals 2. Okay, can't have negative answers because you can't plug negatives into a log. Let's look at example B. Same idea here. Log base 3 of x squared minus 15, log base 3 of 2x. So since the other part's exactly the same, I can go ahead and set them equal to each other. So I have x squared minus 15 is equal to 2x. Okay, then I'm going to move my 2x, so I'd have x squared minus 2x minus 15 is equal to 0. Factor. I would have what multiplies to negative 15 but adds to negative 2, negative 5, positive 3. Set each piece equal to 0. So x is equal to 5. X is equal to negative 3. Okay. If I check and plug it in, negative 3 squared, well, that's 9. 9 minus 15 will give me negative 6. So once again, it's a negative, so I can't plug that one in. 5 squared is 25. 25 minus 15 is 10, so we're good there. That's positive we're plugging in. And then 2 times 5 is 10, so this is my solution. X equals 10. And our very last problem, they are both log base 14, so I can go ahead and set them equal to each other. Get everything to one side, so I'm going to subtract x. Factor. So it multiplies to negative 30, but adds to negative 1, negative 6, and positive 5. So x minus 6 equals 0, so x is equal to 6. X plus 5 is equal to 0, so x is equal to negative 5. And once again, x of negative 5, if I plug in a negative 5 right there, can't do that one, okay? But if I plug in 6, I would have 6 here, that's fine. 6 squared is 36, 36 minus 30 is 6, so that will work out. Okay, so that's going to go ahead and do the video for us today. That will be all. Please, if you have any questions, write them down. Make sure you ask me because I know logarithms are new to you. Otherwise, have a great day, and I will see you later.